The next section we're doing is 3.3, okay? Now, basically with polynomials, well, just like with, you know how with integers, we can actually divide, right? One integer by a non-zero one. And when we do that, we can get a quotient and a remainder. And, we do this, we divide a lot. Like for instance, when we're factoring integers, right? If you know one factor, well, to get the other one, you have to divide. It turns out you can actually do the same thing for polynomials. Specifically, and for integers as well, there is a division algorithm, which is really a theorem. And it says this. If you have a polynomial, f of x, let's say, and d of x is a non-zero polynomial, you never divide by zero, okay? You never divide by zero. When I say the non-zero polynomial, I just mean d of x has to be non-zero at least one x. It can't be identically zero. That is, it can't be zero for every x. Well, then what you can do is you can divide, and doing so, there's a process of dividing, and by that process, we can get a quotient, q of x, and another polynomial, r of x, which is our remainder. And just like with integers, there are conditions that the remainder has to satisfy. It's the same idea here. Namely, r of x has to be the zero polynomial, so it's identically zero, or its degree is less than the degree of d, the divisor. So again, if you take a polynomial f of x, right, we divide it by d of x, called the divisor. That's what capital D stands for. If you divide it, okay, you're going to get two other polynomials, two unique ones actually. One of them is called q. One of them is the quotient q of x. The other one is r of x. Where this equation holds, which is equivalent to this one, you just multiply by d of x. And from here, what has to happen is this r of x is either identically zero, or its degree is less than the degree of d of x. I don't have to memorize this theorem. I'm not going to ask you to, right? Mostly because you have the notes in front of you, for a test or whatever. So we have that. You could leave it in this form, but this turns out to be a little bit easier. How you actually divide the polynomials, that's a different story. Unfortunately, it's not easy. But we're going to focus on the easy case, which is synthetic division. That's where dx, your what do you call it, divisor, is of this form. X minus a, where a is just a number, a fixed constant. We also have this terminology people use. I think they also use the same terminology for integers, actually, when you divide. But when you have this case, it's a little bit easier. I think the book does division algorithm for more general polynomials, more general D, in other words, like degree 2 and higher. We're going to focus on this, though, mostly for time consideration. Okay. And just like integer division gives you some very nice results, like with factoring, we can get some very nice results with factoring polynomials from the division algorithm. And we'll see later, there's actually two very important theorems called the remainder theorem and the factor theorem. Okay, so we have this. So again, this is actually, it is more complicated. It's based on degree, but we're going to focus on synthetic division. Now, what I'm going to do, though, is I'm going to go through the process. I'm going to illustrate synthetic division, that is, using examples. The textbook has more, I'm sure, but I figured it'd be good to go through this using examples and then to let you guys try a few. I figured it'd be good to do that. In other words, I'm planning to give a worksheet. If not today, then definitely on Wednesday. Okay. So here's what you want to do. So let's suppose, so I do have a process outlined, but again, it's still good to illustrate this using examples. Okay. So again, f of x, right? That's the polynomial you have, and you're dividing it by x minus something. So this should be a minus. Let me just quickly fix that. This should be a minus. Before I had x plus 3, but I figured it'd be better to do x minus 3. So anyway, so if we're going to divide a polynomial by x minus something, right? So this is what our f of x is. Now notice also what I did was, for the terms that are missing, terms that are less than the degree of f, okay? Terms that are less than the degree of f, you know, the missing powers of x, I put them in there with a coefficient of 0. If I remember correctly, I think I said to do that when we add and subtract polynomials using the vertical method. We're doing that here as well. So basically, we're adding 0 as, how do I say it, missing as placeholder, so to say. And also, you want to make sure the coefficients are in descending powers of x. Kind of like what I have over here. You know, we have degree 4. There's no x cubed term here. We go right to 2. So I put it in as 0 as a placeholder. Then we have x, and then the constant, same thing over here. Now, also, we have x minus 3 here. We're dividing, okay? What we're going to do is this. We're going to form this little table here, okay? Now, this table is, what's going to happen is you have x minus a, or in this case, 3. That 3 is going to be in the first column. Then the coefficients of cap f, the polynomial, okay, they're each going to get their own column. Almost like what we're doing for adding and subtracting vertically. As you can see, the zeros here as a placeholder. Okay. There we go. So again, that's what we're going to have. We're going to have this little, I guess I could call it a table or a chart, so to say. You can do that. All right. Next, so this is the same one from above. Notice also we had to include the sign. So if we have minus something like minus 63, you have to keep the negative sign. Okay, that's very, very important. Then here's what's going to happen next. The first coefficient, 2 in this case, you're going to bring this down. Okay, you're going to bring this down to the bottom, as you can see. Then you're going to multiply that coefficient by your a. So in this case, 2, we're going to multiply by 3. The product is going to be one column to the right and above. One column, one row up, in other words. So we're going to multiply these two, and then the answer goes here. Let me actually see if I can draw that. That might help if I draw it out. So here we're going to multiply these two together, and the answer goes here. Draw. Yeah, that should be fine. Okay. You multiply these two, and then the answer goes here. Then what's going to happen is, as on the next slide, well, they have the notes in front of you, so you probably see already. This 6 and this 0 you would add, and the sum would go here, as you can see. So we had this product, the answer here. Now we add these two, and we get 6 down here. Now basically what's going to happen next is you're going to repeat the process, but you're not going to work on 2, you're going to work on 6. So in other words, what's going to go over here, we're going to have, as on the next slide, 3 times 6, which is 18, and 18 is going to go here, as you can see. Let me draw it in for fun. So here we have 3 times 6, right? Then the product goes here, as you can see. And then next we add. So in other words, what's going to go down here is -3 plus 18, which is 15, as you can see. So basically, again, we're going to keep on doing the same process. Multiply, put the answer, one column to the right, up one row, add. And you keep on repeating until you get to the last column. So we have 3, so now we have 3 times 15, okay, which is 45. 45 goes here, as illustrated here. We add and get 50. Right? We're making progress because, we're getting to the last column. And it's on the next slide, but let me just say it here. Next, you do 3 times 50. That product goes here, which is 150, and then you're going to add to -63. That's what I'm doing here. So 3 times, that should be a 50. Let me fix that real quickly. We have 3 times 50, okay, which is 150. That goes into the column to the right, one row above. Now we're going to add to -63. And what we end up with is 87. Again, let me say it again. 3 times 50 is 150. 150 plus -63, that's 87. And notice we stop because there's no more columns. We're at the end. So the process does end. Thank goodness. Okay? The process does end. Okay, now what happens? Well, these numbers here, those are going to be the coefficients for the quotient, which is always 1 degree less than your dividend. So the dividend, remember, is what you're dividing x minus a into. So this is always, so these are the coefficients for your quotient, your Q. But you always have, it's always 1 degree less. So our starting polynomial was, I think, degree 4. This is going to be degree 3. I'm asking, it's right down here. So it was degree 4. So the quotient is going to be degree 3. So we would get 2x cubed plus 6x squared, 15x, 50. The last entry here is your remainder. This is our remainder. That's here. So this is your r of x. And then what I do is I write it this way. You have, in other words, f of x equals d of x times q of x plus r of x. Now, if we go back to the here, I'm writing it this way. That's what I'm doing. Okay. Never mind. What am I doing? So that's what we have here. You know what? Let me write it out in pen. So we have f. This is our f of x, okay? That's equal to d of x. As you can see, then we're multiplying it by q of x. Right, that's q of x is what we just calculated. And we're adding it to r of x. R of x in this case is a constant. Again, the degree of r is either 0 or its degree is less than the degree of our divisor, which is x minus 3. So r of x is either 0, identically 0, or degree 0. Okay, let me just stop it.